Okay, so we're going to start this video with learning modules. Here's our first module we're going to learn is the turtle module. So to call on the turtle module, it's like a game mod for a video game basically. So I'm going to call it in by saying from turtle, turtle import all. Okay, so now we have the turtle module. Without this, Python would have no idea what FD100 is. That means forward 100 for a turtle, but there is no turtle right now because there doesn't know what a turtle is. So let's actually try to run this. Let's call this test 2. Okay, FD is not defined. It doesn't know what it means. Alright, so now let's actually keep the turtle. We're going to bring the turtle in. And now we're going to have a turtle. Great. So now we have a few other commands. We can go over BK 100 means backwards 100. RT, you can put RT, see an angle, you can put 90, it means right 90, left 90 as well. So let's see what this guy does. He's going to forward, backward, right, left. He's going to do it really fast. Let's watch it again. Forward, backwards, right, left, really fast. Okay, so we have those four. That's basically like the four moving commands. We also have x equals, let's say 200, y equals 200. We can go to x comma y. So now our turtle is going to go to the specific coordinates. Do that. Another command is pen up. Let's do forward 100. Actually, let's just do this. Let's just try it out first. Pen up, forward 100. So now it's going to pick up the pen. We can put it back down with PD. And now let's do forward 100 again. Now it's going to go forward without a pen, put it down, and then forward with a pen. So let's do something like this. Let's do for I in range. Let's do 1 to 10. So instead of just doing range of 10, I would go from 0 to 10. Let's do 1 to 10, so we can start at 1 actually this time. Oh boy. Okay. Now let's do forward. I times 10. Let's do right 90. Let's do pen up. Let's do forward I times 10. And then RT 90. Let's put the pen back down. So now let's do this 10 times. A cool pattern. You can all do all kinds of cool patterns. It's going to go forward. It's going to pick up the pen. It's going to turn right. Stuff. It's going to basically do this thing 10 times, but kind of follow along and kind of follow what it does. But if you just want to do something easier, let's just do forward right 90. So it's not going to pick up the pen anymore. We're just going to make a box. The same thing, but with the box now. See, spiral box, I guess. We do this 100 times. I don't actually feel like waiting for it to do 100 times, but you get the point. Okay, so next thing, let's do user input. So let's do A is equal to input of. Now you put a prompt here. Say, give me number, and then it's gonna. Now we're gonna get a number from this. Okay, so give me number 3. Alright, cool. Didn't do anything. Now let's do print. Let's say you gave me, and then you put this a comma inside the print, and you can say A. Okay, so now it's going to give me you gave me, and it's going to print out A right after that. So watch this. Give me number 6. You gave me 6. Okay, so you can also do string equals you gave me plus A, but now whenever we do this, we actually need a space here. Okay, so now let's do this, and let's do string, not sting. Give me number 8, you gave me 8. We do that plus space there, whenever we do the plus sign in this space. So now we can also do like a while loop. Let's do this. While true. So it's going to run this while loop forever. put this inside there, a give me number. Okay, we're gonna make a list with these, with the numbers that you give me. So b, so I'm gonna make b is equal to an empty list. Okay, so b plus equals a, and now every single time let's just print b. So let's see what it gives us every single time. Okay, give me number 6, 8. Now it's got 6, 8, 5, 32, 23. Oh, so that's another thing I forgot about that. It'll also split it all up. So instead of this, let's do input. So let's do a little practice thing. We're going to be coming back to the turtle in a couple seconds here. Let's say a is equal to 12. Okay, but we want to do 12 plus 5. So c equals a plus 5. Well, this is not going to work at all. Let's just see what c gives us. See, bang, not going to work. Okay, now we're going to do this instead. Since we know a is equal to the string of 12, we're going to turn it into an actual number. So a is equal to integer of a. Now that turns it from the string. It can it can read this and then make it an integer. Integers are any real whole number, just no decimals. So now we can actually do this. You'll see the answer. It runs. Oh, there we go, 17. So we want instead of doing integer, we can do float. This is just decimal. It's the same thing, but it takes in any number. So you can do 12.5. and a bunch of other ones, and you can do float and add 5 to it. Alright, enough of that. Let's go back to here, and now let's say b is empty. We're going to keep on making b bigger and bigger and bigger. We're going to change it, but instead of it making, before we had it like this where it's strings, we were making it out of strings, 3, 7, so these things were, this is a 3 and a 7 in the string form, but now let's do it as integers. So now a is going to be an integer of a string. Remember, the input gives you a string, so it could be 6. So that's basically what this would be. This would give you the number 6, but then it converts this string of 6 into an integer. So that's what it does in that little thing right there. Now we're going to watch change from strings to now actual numbers. Oh. Yeah, I forgot this isn't actually how you're supposed to be doing this. So actual way is not supposed to be b plus equals a. It shouldn't be that. It should be b dot append a. So let's try this above. Let's try another test. We will get back to the turtle module soon. Okay. Let's say a is equal to 2. B equal to open brackets b dot append a equal to 3, b dot append a again. Now we can see, oh, got to print b. Let's see what b is. So you can actually just type right here b, because b is already, we did this. Every time it restarts, you can do this. You can type a, get a. B is 2 and 3, so that's good. We want this. We want to be appending, not just the plus equal thing. That plus equal thing is more for like string, like a equals hello, and b equals, remember from this earlier, from the last video we did this, c equal to a plus b, that sort of thing. So like, let's just say print c, hello world, no space, oops. Alright, so now we can actually do this for real. 6, 8, 4, 2, okay, cool. Instead of doing that, let's just not do this at all anymore. Give me a number, and now let's just make the turtle go forward a. So now we have a distance as for the turtle to go. We don't need this anymore. So now we're gonna input, we're gonna ask the user for an input, and the turtle is going to go 6, 7, 9, 10. Let's do 200. How about negative 700? I'm gonna go backwards really, really far. So it can just do forwards and backwards sort of stuff like that. I'm gonna kill it. Yes, die. Okay. Another thing you can do is the eval. So let's just play around with this for now. It's not an actual real type of command. You should be able to parse stuff better in the future. But let's say a equals fd 100. Now let's do eval a. Okay, this is going to evaluate this string as an actual function. So let's see what happens. Forward 100. We didn't even type it out really. It was like a string. So now we can do give me a function. So now we can do, and then let's do eval of a. Evaluate a. So let's do forward. Oh wait, is this being converted to an integer? Yeah, we don't want that at all. There you go. That's better. Let's say bk 100. Okay, went backwards 100. Can't even see it. Now let's say write 90. Let's say fd 100 again. Oh, I said write 9. Let's say lt9, fix it. rt90 now. Forward 100. You just see him moving around. rt90, take him so we can actually watch him. Let's go backwards negative distance, so it actually goes forward. Forward 900, just bye. Alright, see you later. Let's say float. Convert this to a float, but not this anymore. Let's make this x coordinate. Let's say b is equal to float input of y coordinate. And then it's nice to just put a colon and space here so that it's easier for the user to input stuff. Oh, I didn't do anything. Okay. Eval, and then go to, and now we're going to plus string. So str is string. Let's play around with that really quick. So if a is equal to 2, and then a equals string of a. Now let's print out a. Okay, well we can't really tell the difference, but let's do print out type of a. Okay, so type gives you like the type, so if it's a string or if it's an integer. So let's do print type a before and after we convert it, integer and then string. So that's pretty cool. So as you can see the difference there. Now let's do go to plus string a plus comma plus string of b plus, and then let's close that. Now we're going to go to what this looks like. So it looks like go to a and then comma b and then close parentheses. A comma b close parentheses. That's what we just did. We just made it like a string, and then we're going to evaluate that string. 100, 200. Now turtle should go to 100, 200. Oh, what? Yep, we went there. X coordinates say 400, negative 200, negative 100. Move. Okay, that's cool. I just want to kill it. In kinematics now. So we're actually going to do a for I in range seconds. Okay, so kinematics is based on x position, y position, x, y, but let's say, then let's do vx, so that's your velocity in the x direction, that's like how fast you're going, but like just in the x, because we have x and then we have y, so let's just say vx is equal to empty, just keep those numbers, 0, but this is 0, and let's do a x equals 0 as well. So accelerate is, there's position, there's velocity, and acceleration. There's higher ones as well, but these are like the main three ones that matter. So acceleration is how fast this velocity is changing, and the velocity is how fast the x is changing. So this changes this, which changes this. But we also need a y. So let's say y equals 0, vy equals 0, and then let's say ay equals 0. Okay, so let's say we're going to make the turtle go to x comma y every time. That's what we're going to make it do, but we need to make this x and y, like we're going to make some physics put into it. So let's say that we're going to start out with some dx. Let's actually put this, so we want the initial position. Since this turtle starts in the middle of the screen, let's make a move a little bit to the right. So velocity and acceleration, let's make it 10, so he's going to start moving to the right 10. But let's put some gravity in there. So every single time you want it to be accelerating downwards. Gravity affects acceleration, which affects speed and affects position. But gravity is the thing that affects its acceleration. So let's say that a of y minus equals 2. Okay. Let's say now x. Oh, we also need a time dependent thing. So let's say d equals 0.01. Every single time we also need to make sure that we kill our accelerations and stuff. So a x equals 0, a y equals 0. Every single time we run this loop over again, we need to make sure everything's set back to zeros. These accelerations at least, because they're being affected by gravity and stuff. So now let's say ay is equal to -2, and now let's say that vx plus equals ax times d. Okay, d is like our time. So a of x is in its units are meters per second squared. So we have 2 seconds at a time on the bottom. Then we multiply this whole entire thing by this d is time. Okay, we're gonna make it as a time, a small increment in time. So we multiply this by seconds. This actually gets rid of one of the seconds on the bottom, so that turns into meters per second. Instead of meters per second squared, turns into meters per second. So now we have velocity, and now we multiply velocity by that. So let's say x plus equals vx times d. So if we have meters per second, we'll multiply this by another second. Second times this s and this s cancel out, so now we just get meters, which is what we want, SI units, but still you get the point that this is how you would affect from acceleration multiplied by time again to get position. So let's try the same thing with vy. Just copy and paste, change it to vy, ay, and then y plus equals vy times d. Okay, vx, vy, yx, ax 0, ay. So let's just do this for right now. See what happens. I don't know if anything's going to happen actually. Seconds is not defined, so let's make seconds. Seconds equals, let's say 10. I'll make 100. See what happens. That wasn't very much. Disappointing. Let's make this 0.1, so this is how fast time moves. So 0.00001, that's going to be super accurate, but 0.1 is going to be less accurate, but it's going to make time go faster. Let's do a lot more seconds too. There we go. We get a nice curve. There we go. So, because we started out with Vx of 10, so let's say -10 now. There we go. And now let's say Vy of +10. Now it's going to be going up and then down a little bit more. So let's say that Vy is equal to 100. Now this guy's going to be flying out. Probably can't even see that. Let's make that a little bit different. 50, probably can watch that. No, apparently too much. Let's say 20. Probably wouldn't be that much. There we go. You see that curve. It's just basic kinematics, but it's a very basic physics thing. Now instead of this, we can do more complicated things. We're going to get into a physics simulation next video. Let's add boundaries. So this guy, let's make a box so that whenever he hits like a wall, he's going to hit that wall, bounce and bounce around again and everything. Let's do that. So let's say that underneath this, before the go-to, but after all this stuff, it doesn't really matter because they're in a loop, so it's just going to affect stuff anyways. But but we have to do this kind of after this x and y are defined, because you're gonna see we're gonna have to change it a little bit. So let's say if x is greater than, or greater than, let's make size. Okay, let's make a variable called size. So size of our box, let's make it 300 pixels. 300 pixels this way, 300, you know. Well, it's actually 600 across, but like, you'll see. So if x is greater than size, then we're going to do, so if x is greater than 300, we actually want to make it bounce off that wall. So what we need to change is the velocity in the x direction, if the x thing here. So we need to make it bounce, hit this wall, and it needs to bounce. So we need to switch the velocity in the x to be opposite. Whatever it is, just make it opposite. So let's just do vx equals negative vx. Okay, that's all you need to do. If x is less than size, vx is equal to negative vx. Again, it doesn't matter, just multiply by a -1, because sometimes it'll break down and everything. So if it's greater than that size, let's say x is equal to size. Okay, and we're also adding some friction too. So let's say friction, I'm just going to say f. F is equal to, let's say 0.9. So whenever it hits a wall, it's going to come off at 90% the same amount of speed. So if it's hitting down here, it's going to lose half, or it's going to lose 10% of its y velocity. If it hits this wall, it's going to lose 10% of its x velocity. So let's do that. Let's just do negative 0.9, or not that, let's do f times vx. So negative f times vx. So negative f times vx. So it's a -1 and a 0.9 times whatever our velocity is. And let's say underneath here, x equals negative size, because it's less than size, it's this size. Alright, now let's just copy and paste for y's. Same thing exactly for y, and y at the top and y at the bottom. Alright, vy, vy, vy. Oh, I forgot something here. If x is less than negative size, if x is less than negative size, that's what we need. Or y, yeah, that's a y. A y. Alright, y is equal to less than negative size. Okay, that should work better now. Forgot about that. Let's see what happens, if anything. Nope. Oh, it hit it pretty good in the corner. That's like a perfect DVD bounce. So it's losing a little bit of speed every time it's a wall. Oh, we ran out of seconds. Oh, that was boring. Let's change these around a little bit. Let's say vx is equal to 100. Don't know what's going to happen here, but seconds, let's just crank that up. Now you can see we can change this D. Let's make this D number 1. See how inaccurate it is now? It gets really, really janky, but if we make it D 0.0001, it's very, very slow. It's barely moving. Let's make this tenfold. You can barely see it still, but it's much, much, much more accurate. The slower it goes, slower this D is equal to. It moves little tiny more increments, so it's much more accurate instead of moving big steps. Let's just keep this as well as a 0.01. Is that decent? Is this a decent number? Yeah, it's decent. Nah, it's pretty slow. I'm getting bored. There we go. Make Vy equal to not this. Let's just keep it though. Let's just say that Vy equals 0. So like if it hits the ground, let's just make it so that it just boom hits the ground and stops there. So if it hits the ground, like if your player jumps, hits the ground, they're just gonna stay on the ground now. That's pretty cool. Okay, so the next thing I want to add is how to get like a new module, because like we want to be able to jump. We need to be able to detect that we're pressing an up key. So we can't just do. We can do with the turtle. There's a special thing you can do in the turtle library where you can detect keystrokes, but it's really kind of janky. So I'm gonna get an external library. So we have the turtle module that comes with Python, but there are other like tons and tons of stuff online and modules that don't come with Python. So we need to kind of get it ourselves. So how you do it is you just go here, type in cmd, so you get the command prompt. And this one's going to be called keyboard, so we're going to go pip 3, or pip install keyboard. I think that's all you got to do, yeah. And then now you wait, and it's going to do some weird stuff. I have no idea what's going on. Oh, you need upgrade pip. So sometimes it gives you this. I mean, I don't even know if it makes a difference or anything, but I just kind of copy, Control C, and then Control V, and enter. upgrading tip. I don't know. Really, just do it. And there's plenty of libraries online. We're going to go into a couple other ones later. But so now we have keyboards. Now we can do some new stuff. Okay, so now we have it downloaded. At the top of here, let's say import keyboard. Okay, so sometimes you do from turtle import all. Sometimes you just say import keyboard. There's different ways you could do it, and you have to like add in like a dot. So I'll show you what I mean. So if I actually would say, let's do a practice, something else. Import. Another one's called that comes with Python's called math. Okay, so now I could do print math.py. Okay, I'm gonna get rid of the rest of this program because I don't want to break anything. Okay, so if I have math.py, print that one. Okay, 3.14, whatever. Cool. But now if I do from math import all like this, now I can just say print pi. There's a little bit of a difference there, but it just helps separate out whenever I do like just import math. Now I have to put math.py, so it will be the math libraries.py instead of like some other libraries.py. It helps separate out stuff, sort of. I guess, I don't know. I don't really know what I'm doing anyways. Let's have a jump, so let's add some velocity in the y direction whenever we press the up arrow key. So let's say if keyboard dot is underscore pressed. This is the special command I have in it. So let's say maybe say up arrow. Alright, now this is going to not say vy plus equals 10. Okay. Now this is we're going to call this a jump. Let's just keep track of it. Jump. Let's put a little comment right there. Alright. Let's see what happens. Up arrow key. Boom. It just flew. Okay, maybe let's make that a little bit less. Just make that 1. Okay. Bounce a little bit. So if I can hold it in, it just flies like a jetpack. Let's do the same thing with left and right. Let's make it go left and right now. So let's say right arrow, right move. Let's call that. Let's say vx plus equals 1. Yeah, let's do that. And then we're gonna make a maximum velocity in the x directions from these things. So let's say left vx minus equals 1. Call this left move. Alright, cool. We have that down. Now let's just keep this. So let's say if vx is greater than, let's say 5. Let's say we have to keep track of it then. Let's say vx og equals vx. Alright, we're gonna keep track of this vx original, okay? Time traveling variable sort of a thing. If vx is greater than 5, vx is equal to 5. If it's less than -5, vx is equal to -5. It's like a maximum velocity of the left and right. So we're gonna go that fast. Alright, why can't we jump? I want to do a little jump all around the ground. Let's just move all of this. Cut. And right before this go to. Alright, let's do some little fixing. This is saying vy is equal to 0 afterwards, after we wanted to jump. Yeah, I'll put just this jump after this one right here. This one. Cut. Left move, paste, right move, okay, jump. So now it should be after the 0, we can still be able to add stuff. So left, right, still moves, works good. Jump, jump, jump. Okay, but we want to really well jump, double jump. That double jump is bad. Now let's worry about that later. Let's make a opposite but down arrow. Just be able to slow it down. Say minus equal. Let's say 0.5. You can also make the maximum velocity and the and let's make it like, let's make it 10. Sure, 10 sounds good. Here, 10. Let's make this 10 and 10 more. There we go. OG on ground. It's 0 because he's floating in the beginning. On ground is 0 in the beginning, and then whenever we are on the ground here, OG equals 1. And then let's say inside of here, if OG equal 1. Has to be on the ground to be able to jump. Okay, on ground 1, 0 until it hits the ground. Whenever it hits the ground, it turns the on ground 1, and then if on ground 1, we're allowed to jump. We can jump. Okay, I can still infinitely jump though. Oh, and then after it jumps, we need to be able to say that OG equals 0, because now once we jump into the air, we need to be able to say, oh, on ground is not true anymore. Nope, can't jump. Why can't I jump? I want to be able to jump. Alright, there we go. Now we have it working. Alright, I did a little bit of debugging, so I was just printing out OG right here inside of this to figure out like what's the 1 and 0, if it's on ground or not. So just help me debug that a little bit. So now I made the jumping 10 because it was like not working very well, so now I can go fly down and then jump only once, jump. So also I want to make sure that we can't control ourselves in the air, because I feel like we shouldn't be allowed to like jump and then control ourselves like this. So let's fix that. Let's say that if on ground is equal to 1, copy, paste. Okay, so now we can move left, we move right, jump, can't move, jump again, move down in the air. More thing. Oh, before this actually, let's not do seconds anymore. Who needs that? Because we're just like running it for a really long time. Let's just make it while cont equals to 1, and let's just make continue equal to 1. There we go, problem solved. Now we're just gonna run forever until we can make something in here, make cont equals 0. So let's say I don't know, what's something you never press? P cont equals 0. Alright, now that would it's gonna die whenever you press P, because who cares about P? It's just like a useless one. P dead exit. I have no idea if it's gonna work, what it's gonna do. Let's figure out. Alright, P. Cool. Let's make it a little bit of edge detection. Let's say PU go to -300, comma, let's say 100, and then let's say LT 90, and then forward 100, and then let's say RT 90. Oh, bad. And let's say forward 50, and then let's say RT 90, and then forward 100, and then let's actually do this. PD, and then there we go. I'll go -300Y and +100X. Here, just to pretend edge detection, let's say if X is greater than 100 and with -300, -200 now, so now X is this way, and it's supposed to be this line right here of edge detection, and Vx is greater than 0. Hello. So let's say whenever we hit this side wall right here, we want to print hello. Bang. Hello. Alright, let's make this bad boy stop a little bit of friction. Okay, I just realized I was doing it wrong, so I changed a couple things. The only thing I changed, okay, is I put xp is equal to x, so I mean this as x previous. So, I don't know, like x before, you know, I want to make it like a time traveling variable. So, what I call time traveling variables is whenever I want to make this x, like this is defined as x right now, but now through all this stuff, x is being changed, like x plus equal, you know, all this kind of stuff's changing x, but I still want to use it down here later, this previous x, not this new x, but I want to compare stuff. So I'm actually going to use this in like kind of like a time traveling variable, you know, because it holds the old value of x and y through all this stuff. So let's say x previous and y previous. Okay. So now I said that if x previous is less than 100 and the new x now is greater than 100, so that if our line of our wall is right here, then that means previous x was here less than 100, and now x is on the other side of the wall is greater than 100. And we have to say the y is between a certain range of the height of our box thing. That's like the height of it, but that's just less than, it's greater than -300 and less than -200, inclusive with the equals. So it's like, has to say that it's between the height of our box, and it's before x is here and the after x is to here. So we know that it's going to be crossing within this line. It's going to be crossing over, and we need to switch the direction so we can hit the wall and bounce. That's basically how we check that. So in the second one, basically the same thing. We'd have like this x. So this is the top of the box now. So on the top of the box, it's x is between 150 negative or 150 and 100, and then y previous is negative 200. So say that it's bigger than negative 200. So let's say it's about up here now, and then the new y is now less than negative 200. So before previously it was above the negative 200, and then it fell through the 200 within the range of our x here, but it fell through. So we need to know we need to make a bounce and switch this vy, so make it bounce. A little bit of friction, but still. I'm gonna do the same thing here. I copy this, but the other side of the box. So now we need to do if xp, the previous x, was bigger than 100, so it's over here, and we're going to cross over this way. So it was over here before, and then it crossed, so it means that now x is less than 100, but it's actually 150. This is the right side of the box, is that x coordinate 150. So you need to cross over this thing here. That makes sense. Now that the old x was bigger than 150, now the new x is less than 150, and it's within the range of our y from negative 300 up to negative 200. And vx is bigger than 0, so vx is less than 0 now, so this is going this way. To the left is negative, and positive is right, so let's know that one. Then vy is negative to hit the top of it. Good. Let's hit this. Oh, perfect. Let's make our bounce, make our jump like a lot more. Let's make it like 40, 30, probably fine. Let's try 30. Oh yes, score. Yep, and let's see, bounce. Oh, yep, works. Alright. So that's how you make kind of like a really basic game right now. You can draw boxes around, you can draw all kinds of stuff. You can also change, let's say, color to, let's say, green. That changes the turtle color, say BG color to gray. Oh no! I'll say that. That's the background color and the color of the turtle, so it can change its color around. Let's also change shape to an actual turtle. Bang. How about that? Now we have an actual turtle flying around. Oh, it's upside down. Oh, you can do circle instead. That's a circle. You can change the size of it as well. So I'm like, oh, I forget what the command is for the size, okay? So what you do is turtle library Python, and then it's good enough. Then you just like go through here, and it has like a bunch of stuff. So here's like an example, a couple stuff to learn. Just really practice. Here's a ton of stuff: forward, FD, backwards, BK. You know, with all these things: position, towards, X core, Y core, all this stuff right here, PU, PD. And you can just go online and look up all this stuff. Same with our keyboard library. You can probably look up that stuff too. Oh, cleared it. Let's go. Alright, later.